Welcome back to another short video. In this video, I want to write some program with Go, and this is directly inspired by the Learn Go with Test-Driven Development series. And in that one, we were learning about concurrency, and the program that they drew this upon was checking the health of a website, of a URL, which if they pass a URL and if the status code after pinging it comes to 100, that means that that URL is healthy, so it returns true for that. So I wanted to, and even though it's very simple, I just wanted to implement that on my own, by just just doing it as people who do pre-LLM era, search about Go syntax, make requests and stuff like that. And yeah, I'll see what we'll learn along the way. So here we go. So we have a basic Go template ready, and so the idea is quite simple. What we will do is we will have a function that check website health, which will get an URL, right, and return a bool. I think that works well for now, right? So it pretty much takes in our website URL and will return us a bool, and this there'll be some logic that goes in to check if the website is healthy or not. So I don't know how I do that. So how do I check status code for URL in Go? So I don't really know how to do that. So mm, right, so I think I got a Stack Overflow, so let's just learn as we go. I wanna um can't be that hard, right? Yeah, capturing the HTTP status code, I think that should be it. um Capturing um mm, okay, I don't want to do this. um okay, I think it's like something like ping, right? Oh my god, why is it like this? So yeah, over here it says ping, so HTTP dot new head. Yeah, so we don't really need to do this. And it says request slash error is equal to http dot new request. I don't know why we're doing head over here. And then we have a client, which is http dot client is equal to um what the hell is this? um it's taking way too long for me to like to get the http status code for URL and go make the http request. Okay, so apparently I just say rsp error is equal to whatever this is. Always close the response body. Okay, and do not intend to read the payload user to be head. Oh, okay. Okay, no wonder you use that. No wonder we don't use head over here though. Um, wait, chat. That was talking about it. Wait a minute. I think this is it. But I don't really understand why we need client. So is client used though? So this is a ping function, and um, Okay, so apparently this is a function, and so the way I do this is we say something like RSP, which is a response error, is equal to http dot head, and this is the URL, right? And then we'll say if error is not equal to nil, which is kind of shit, we will have to do um, um, something like bool and error, and so we can return. I mean, we don't really know what to check, so false. Um, Errors. How do I do an error type over here? If I remember, error dot new, right? How do you do that? Error dot new and go. I forgot the syntax. Errors dot new. I was right. It was errors. What am I doing? Okay. Um. Right. So I can use something like errors. So something like errors. Okay. Can say fail to like fetch it or something. Right. Yeah. This is just the bool, right? Like yeah. I mean that's sort of okay. Let's just return status code for website. Okay, I'll change that a little bit, and we will say 0, and we will say um, fail to send. I would say like request. I think I'll be using this code. So http.head, so we don't get in everything else, and network error occurred, and then we say differ. So I don't really know why it occurred. Inverters dot body dot close, and then we say print raw text, print raw code. What do you mean by print raw code? What is this? What? Ah, my bad. Yeah, nil. Yeah, right. Okay, chat. So now if I, so now we have a function that just gives me the status code of a URL, right? So if this is correct, if I can do printf status code for Google, right, and I'll say status. And to be honest, you don't want to do this because it's gonna say status code error status code. To be honest, let's just assume कि error नहीं आ रहा है. I mean, if error happens, then we'll just panic and go. What does we mean? What do we mean by panic? We'll just panic, guys. We'll just panic because I feel like it will be a bit of a troublesome at the moment. But we'll say panic request. Even though this is kind of bad, you don't want this because this you wanted something to fail silently. But this is kind of bad. Now that I think about it, if I do fmt.printf status code is equal to for Google, I'll say status code, and I'll say obviously I want to do something like right, and you want to pretty much go over here and right. Okay, chat. Let's see if this works. So I say go run main.go. So status code is 200, which is great. So that means this is kind of working. I want to see if this works for um I just remove all of that. Like I want to see if this works. Yeah, panic request failed. And I think the reason why it failed is it traces back. We're gonna do this. We wanna give HTTP. Um, yeah, we don't worry about that. Right. So okay, that's good. Now let's do something very fun. Um, now I think what we wanna do is, let's say we'll have something like URLs and status code. Um, right, and mm, and we'll have some value over here that doesn't really. What's the issue over here? Um, yeah, I knew about that. Something like this. Yeah, my bad, I did that. Ah, okay, so it's weird. Uh, okay, I don't know why I just make there for some reason. Right, so we have this, and so I can say for URL, where's for URL? I just want to check URL is equal. I just want to check for my own. Um, okay, okay, let's just run this. Great. So let's just get a bunch of. Let's just get twitter.com as well. Right, let's just get twitter.com as well. Right. So what we'll do is we'll say URLs status code URL is equal to, this is very bad to be honest, status code website. If it panics, we can just return -1. Right, like that's good. And we can give it URL. Let's run this. Okay, and let's go something like fmt.printf, and let's print URL status code, and let's run this. Okay, so as you can see, oh, 403, that's interesting. I wonder what 403 means. Let's go Stack Overflow as well. Stack Overflow, let's open Stack Overflow, and let's just add that so anyone can just come up and add this, and let's just run this. I just want to see if we have this bunch of things. Hmm. So, okay, so we have map and we have 403. Wait, what does 403 mean? Also, apparently Xcode is not 200, which is okay. Okay, okay, no worries. So that is just we're trying to find out the status code. Um, how do I time my programs? I think there's a command for this. Go run clock or something. Ah, measure command. Okay, so this should work. Okay, so total seconds. It takes us around 4 seconds to get this thing to work. So let's, okay, this is right now. Make it right, then make it work, make it right. So how can we improve this? Um, Um, we could I mean, how can we improve the code type of this? I mean, we could make this a type where we can have a URL with the status code bundled together. That could be possible. We could have like an array sort of that, and you can print that. But I don't think that's too much, right? For the sake of this demonstration, we're just trying to have. So now the thing is, how can we make this faster using Go routines? That's the thing. So the simplest answer would be to just do something like Go, right? You can have something like Go. Okay, well that doesn't necessarily work. Um, I think we watched a video on this topic. How do I use Go routines with for functions? Like how do I use Go routines? So we have this function, so we can do something like Go this. Um, oh funk this. We so we wanted to. Hmm, interesting. How do I make this work though? Because the thing is, I want to then store this in this map, right? So I can't just say, so let's just run go over here. Even though I want to do that, I can't necessarily do that because you want to save. Okay, so what we can do is um we can make a func call um and wc, which is a func which takes a URL string and returns an int. Right, so what we can say, because that will contain the URLs, right? URLs. Again, we can do the same thing. We can say URL also, if I want to make change to the URL, I might as well just pass a pointer to that. Is that because Go will make a copy of it, right? What? Ah, okay. So it seems like okay. So it seems like I don't need to do this because Go apparently passes it by that. And if I see this works, what we can do is we can say set status code. I can say URL status code, and I can give status code for a website and ulta dal diya, and I can say set status code for a website, and then I can say URL status code. Cool. And now if I run this, let me just run this normally. Um, okay, so this works. Let's time this. This takes around 7 seconds to run, which is kind of slow. We don't want to do that. So how can we improve the speed of this? Can we improve the speed of this? Okay, you know what? Let me look at how learn go with TTT. I want to look at the example they did because they had a better code on this concurrency. Um, so okay, they have a better code. So yeah, they had a website checker type. Which is fine, I guess. Um, then they, and I don't really need to care about this. Uh, Come on, website checker. Okay, URLs, which is a bunch of okay, yeah, okay, and then returns a map string bool. Yeah, this is fine. And how does it actually run the actual thing? Like, um, like where is the status code checker? I think we can do something like that. Yeah, I think we can do something like that. So what I can do is we can say something like type. We can say something like type status code checker and status status code checker is fine, which is a func which takes in a string and returns you an int. Correct. And then we have check websites, right? So let's have this function as of now. Like, let's just remove this and let's just put this function in. So I copied the wrong. Yeah, let me just take in this function and let's just remove that. Okay, so we have my bad. Let's have something like status code checker. We'll call this SC for intents and purposes, and we will call this SC, right? What's the issue? Yeah, I know what the issue is. Um, Sorry, my bad. Int. Yeah. So yeah, that's pretty good. And so in the main function, we will have a bunch of so we will have a bunch of websites that we want to check this on. Right, and I think we can do something like this very fancy. We can say results is equal to check websites status code checker websites, right? And then I can do print. Oh, what's the issue? Oh, I didn't even define and I removed that function, didn't I? I'm such a smart kid. Let me just come back. Why did I do that? Um, why did I do that? Um, yeah, so something like type. Do I really need to do a type? I mean, it's good for dependency injection. So status code checker, and we essentially just takes in it's a func which takes in a string and returns an int. Okay, and then we have, you can just instantly just remove this function and just say paste this and pretty much do the same work that we did before SC. And this could be what is this? This is status code checker, right? And this thing's gonna return an int, right? This thing is gonna be an int, and this is gonna be SC. Okay. I'm just having integers being passed through, so like status code getter, something like that. I think that's much getter. Okay. Right, so we can have something like status code getter. Okay, so um yeah, so this seems fine, right? So now I can have something like websites as before added, and I can say results, which is equal to check websites. um, it's a status code for a website, and websites print sorry fmt dot print f so you can say okay chat. Okay, this is wrong, so it's not gonna give an error per se, but it's gonna just return, according to the code, it's gonna return -1. So let's see. Yeah, so as you can see, 200, 200, and this -1, because I think we should put some sentient value over here. So most likely cent sentinel value or something. What do you guys say? Sentient value or something like that. I don't know, some weird name. But yeah, this is some error code, because status code range between, they can never range negative. So when someone sees negative, they should be like, well, something is wrong, right? So okay, cool. So this is our basic functionality that is working, and let's just look at how they are implementing it. Okay, so the way they do this is okay, so think of this as our main function block, and we're writing to the same memory space. So this is our common memory space. Think of it like a shared variable, and we are essentially, what we're doing is we are writing a go routine, right? So now how we optimize this? Now first of all, let's time this first of all. So we have a baseline of how long this takes to write. Right, it takes around 6 seconds, right, which is a lot, right? So what they do is, when they come over here, what they do is they say go func, and this is making an anonymous function and then running it as soon as possible. What this does is it says results URL is equal to sc, I think, URL. Sorry, sc, my bad. What's wrong in this? What's wrong? Cannot index. Oh, my bad. What am I doing? URL. It's essentially, what it's doing is creating a Go routine. So you can imagine that this is creating like the number of Go routines are being created as number of URLs we have. So as we have like 3 URLs, we will have 3 Go routines, so to speak. And if we were to run this, I think there'll be an issue with this code. Let's see what the issue is. It returns an empty map, and there's a very specific reason for this. Why this happens is because this is a Go routine. Main is a Go routine itself, right? So what exactly is happening is, if I'm able to articulate this properly, is go the main function in the Go is a Go routine, right? This is okay, the main function is a Go routine, right? Then we create one Go routine, and we create another Go routine, another Go routine, like for 3, and they are executing, right? They're executing, but as soon as they are executing, this main thread completes its execution, right? Because it doesn't have to wait for them, it completes the execution. So we have to find a way to say it to stop, right? I don't know how to. Yes, it says like we'll just stop. We'll just tell it to. I think the way we can say this is, we can say time dot sleep. We can say go to like sleep for a bit, and we can say 1 into time dot time dot time dot second. So this is, we can say the go code to like wait for 1 second. So it finishes the error, goes through it, and it waits for 1 second and see if you get any return result. Okay, so 1 second was enough for it to wait, so you can get all of them. But if you see, if I remove this, if I don't remove this, but if I comment this out, our go routine, the first main go, okay, our time is not in. What do you mean? Oh wow, they are very opinionated about their inputs. Almost reminds me of Rust. So returns empty. So but this is not how you like to code this up, right? Because it's like you want to. So the thing is, how would I would like to say this? I would like it to. So I would like the main go routine to wait until all of the go routines are done, and then it starts its execution. That's what I wanted to do, to be honest, right? So how do I make the main routine to wait for all coroutines to finish before proceeding? Right, before we wanted to wait, I think it was 6-7 seconds. So to make the main wait for all the coroutines finish, the idiomatic way is you, yeah, so essentially, if you remember in Java, I don't know if you guys have in Java, if you ever learn multi-threading, The way they do it is something called dot join, and they call it over the thread that you want to wait for. So until that thread is not over the until that thread is not done, main will not proceed. So we have this is called sync.wait group acts as a thread save counter. You increment the counter when you start a goroutine, decrement it with the goroutine finishes, and the block of and block the main routine until the okay. So how do we do this? I don't understand this. They use this. They use something like sync group. Oh, they're gonna teach this. They're gonna teach this up ahead, but I don't think I'll have the luxury for that. Is used to block the main function or go routine until all. Okay, so I'm a bit confused. How do I know when the go routine finishes? Because this go routine is gonna just keep on going. So that's a bit dangerous. How do I do that? You can move this, and this is like a normal function now. Right? It's anonymous function is very important. There are one of the ways how you do run coroutines is to wrap it around some anonymous function, as you can see. Yeah, but if I run time this just for sake of without coroutines, we get 2.6 seconds. Why though? It's weird. So it's L. Mm, okay, how much is it now? I think maybe that's an unneeded abstraction on there. Um, well, done that now. That's proper. So it's 6.09. I'll run it for like 3 times to get like a proper average before we use the coroutine ones. Again, this is are they caching the results? Yeah, total is 2.9. Okay, what? 2.9 seconds, 2.14 seconds. Um, um, it shouldn't be like this. Is it just 2.17 seconds? One more time I'll run and then I'll give up. Yeah, it's 2.53. So it's somewhat capped over here. Okay, so we'll just get rid of this, get rid of that, get rid of this, and we'll say go. Sorry, go over here, and this will make a go routine. Now the question is how do I use wait groups? So we have a wait group, create a wait group, and okay, so you can see that this is running this anonymous function with the item, and it adds it. So I'm assuming I have to. This is doing it before this runs. So before this runs, and wait block until all coroutines called done. Um, defer means it's gonna access this. I wonder if I do this in that. Okay, let's just use this like that. So I think we'll do that. So we do something like let's call what is it called? Sync. And yeah, and what do we call it? Var wg sync dot wait group. So we're creating a group. Okay, and so before it actually starts, we want to do wg dot add one. So we add one to the wait group, and when this coroutine finishes. Okay, so it's inside the go func we're calling wg dot done. But it's not technically finishing, right? So anyways, I'll do defer wg. I think there's something is going on. But okay, wait a minute, wait a minute, wait a minute. Okay, so we added over here, and then we call defer. Shouldn't we call defer over here, chat? That makes sense, right? and wg.wait. Okay, let's run this code. I think something will go terribly wrong now. I don't know. Okay, nothing went wrong. Let's time this, I guess, so nothing went wrong. Wow. Okay, the speed up. I don't know whether am I doing something wrong or right. I'm a bit confused. So we make the simple. Before we start the coding, we add a counter, and after it is done, we defer it, and then we wait for all of them to be over. Right when the counter becomes 0, and then we return the results. So then the go has to wait because this itself is not a go function. Because this technically is, you can think of it like a blocking call until all the, that's weird, yeah, until all of them, but it's still, there's not blocking though because main function was able to stop. I think within three, okay, now the speed up is clear, like now you can see the speed up that we got. Yeah, I mean the speed up was a bit clear. If we were to add more to this, I guess, like twitter.com, um let's remove this. Let's add more and try to like stress test this, to be honest. Stack overflow. Okay, let's try stress testing this now. I think this is right. Wow, it took 5 seconds. Um, non-go.go. Non. So this is like sequential.go. We'll call this as. What did I say? I want to like benchmark it because I'm like confused. Like, how fast is this, right? Because it's 5 seconds is 5 seconds, right? Let's do something like package main. Let's take this entire code and what's the issue? Redeclared in this block. Just give me a moment. Facing some issues over here. Oh, acha, understood. Yeah, pretty much just taking that as a scope for that. So anyhow, yeah. So this should give us enough benchmark because this is not good routine. So now if I say cd sec, and if I actually just run sec dot go, and now we have like 1 2 3 4. So let's see how long does this take, because that would give us a fair comparison. I'm so confused. It gives 6 seconds. 1 2 3 4. What all websites are there? YouTube, yeah, youtube.com. Okay, let's give youtube.com. And actually it said defer to use over here, so I think I'm gonna do that. To be honest, I feel like we're still bottlenecked by the slowest operation, but anyhow. Okay, let's run this, see what happens now. So very slow, takes around 8 seconds. Cool. If you go cd out of this and we run go dot this now, see what happens. It does that in 4 seconds, so it's clearly half as fast, right? It's clearly like it takes half the time to do that. Okay, that's interesting. Let me just run this one more time. I feel like they're caching the results. Now it's 2 seconds. Like, how do you make that jump? How do you make that jump? So let's run this command again. Again, this is sequential, so again this takes 3 seconds. I'm doing something wrong, clearly. Actually, let's go through. So yeah, they talked about channels. Let's see about how channels work. So essentially what it's the problem that we are facing is key results is a shared variable. Each thread can be able to access it and do it. But they're saying that this could lead to a data race condition, which I am a bit confused. How can it? Um, yeah, I wonder. Go test race. And when I do this right, it doesn't actually work. Go test. Actually, yeah, nah. Okay, channels. We can solve this data by coordinating channels in Go that can both receive and send validate these operations along the details along. So yes, pretty much we store the result of this into a channel. So we make a channel, and then what we say is we say, well, now we iterate over the length of the URLs because we know the result channels will have as many. Then we pretty much take away from the content of the channel and put that into, I think this is some kind of struct, right? And you put that into that. Interesting. So how to use channels? I think that's what Google said to me. If you see over here, right before this it was. Um, so we can say channel um, pool. Interesting. How does this make? It's a channel result. So it makes a result stuff. Okay, let's try that. So we'll have something like type result, and you'll have struct, and it says, well, we don't want to have that, but I will have that. So and we'll say status code will be an int, right? And so what we'll do over here is we will make a channel. So we'll say results channel, which is equal to making of a make a channel of this type. Okay, so we make the result of this channel, and essentially what we do is I'm working on the sequential code, which is not that cool. Um, right, let's come over here and let's just paste this, and we'll create. Okay, instead of using this, I think we'll get away with this. The thing with if we not use this, right, I will show you about that. If we go run main.go, it's a empty map. So let's see if this solves the problem. I doubt it doesn't, but regardless. Also, how do you ping it though? I'm confused. How do you ping it? Anyhow, what we do is we say results channel, which is make chan of result struct. And so now what we do is instead we say results channel, and you're putting into this. And what are we putting? We're putting results URL is equal to URL, and status code is equal to sc URL. Right, so you're putting this struct into our result channel. Okay, and then we are saying for I is equal to 0, I less than the length of it as length of URLs I plus plus. We will essentially just say we will pretty much put this in R first of all. So this R becomes predicate from the channel. So we'll say results channel. So now R will be of types result, and then we say results dot R dot URL. Okay, is equal to R dot status code, and then we return results. Okay, I think okay. I'm happy now. I'm happy now. Let's see if this still works. Okay, so now we get all the results with this, right? So let's try to measure the how good this is, and remember this is was the time we got. So let's do main.go and see what we see. Wow, so it takes in 1 second. That's great. So let's go sick and let's run that command. Yeah, let's see how long it takes. So it took us around 1 second to run that code, and now it takes us 3 seconds. So that's bad. Okay, so I think we understood what's happening over here. So we are making a channel which allows us to synchronously pretty much. Okay, let me just ask ChatGPT how. So I learned about Go routines in Go. What about channels? What problem do they solve? And what problem do they solve and how do they ensure that threads can communicate with each other to. So if you think about it, right, if you really think about it, results channel, so our main variable is results, right? That is a result, that is something that we want to return to the user. We can't afford it to be corrupted. But results channel is also like a shared variable you can think of, right, but of a special type of channel. So this is also like a shared variable. So how does Go ensure that doesn't happen, right? That's one thing. You can replace this with this. um Actually, what are we trying to say? What's the underline for? Anyhow, this is a great question because it gets to the reason channel 6 is go routine solve execution. A routine. That's okay. And yes, this is pretty much you learned in OS. Um, yeah, Go as mutex. Instead of okay, don't communicate by sharing memory. Share memory by communicating. I still don't understand this. Imagine a worker computes something instead of worker writes does worker send result channel receiver. Okay, example, we make a channel of int which will store an int and we say go func and this pretty much puts 42 into the channel and then we put that value into value. This worker never touches a variable, it simply sends data. Why is this better? Because 5 workers produces numbers without channels. Everybody wants the same size. This requires log right channels. Only collector modifies the slice. Worker never touches it. It's a thread safe queue. Think of this. Yeah, I mean, obviously. So, okay, so what I'm trying to say is it sends all of this, and then whatever is finished. So I'm assuming this sends it to the channel. So okay, so the moment this code is ran, right? We essentially make so let's say the number length of URLs is how many Go routines we are pretty much spawning up, right? And so this makes let's say three Go routines. So Go routine 1, Go routine 2, and Go routine 3, and those things are doing this. Whatever they calculate, it goes into result, and that is you have a channel which then takes these values one by one and then gives them out to our some variable r. Before then we use this. So this receives it and then this takes it. So ये भी डाल सकता है, ये भी डाल सकता है. So I'm assuming this is waiting for it. And okay, interesting. Yeah, I want to truly understand how this works because I do appreciate this. Actually, might be the best examples. Okay, so the entire function. So this creates an unbuffered channel. Think of it as a pipe. Um, Okay. Okay, interesting. So they're saying to don't just pass it directly. You can have it something like URL string, and we just say okay, cool. Okay, bro. Yeah, so that was cool. That was cool. Not gonna lie, that was kind of cool. Yeah, so essentially it's like unbuffered, so it pretty much it's like a queue. Yeah, that makes sense. Okay, then we'll do that next. Yeah. Cool, man. That was fun. This was like a fun little exercise. In Go, I can see how this is like a blocking operation because what is it? It's trying to say that okay, give me something from results channel, and this has to run exactly 3 times. But yeah, this was fun. This was really fun to code this up, and yeah, man. I think that was a fun little exercise that we did with Go. And yep, I think that's it. And I will be learning more of Go because I like this approach to Go routines and channels, and I think we still have to learn about sync, which this conveniently covers. And yeah, I think that's cool. Thank you so much for tuning in for another not late night, but a Go session. So see you. Let me show you my face. I think you guys can you guys see my face? Yeah. Okay. Bye bye.